All right, let's do repeat 15.8, right? So I also lost that recording audio. So let's do this. Problem 15.8 is the last weld element we're going to work on. Also on the metric templates, so I'll just continue. It's going to set up the same way I did 15.7, essentially use the same template, use the same kind of weldment style and part style as well here. So we're going to recreate this particular drawing, which is two parts assembled together in a weldment with some couple of weld symbols called out there, how we're going to join those together. So, and I think I've said this one is this is my favorite probably. Well, it's not a perfect thing, and there's some things I've thought about, having drawn it a second time around. But it still is maybe one of my better kind of weldment portfolio drawings, honestly. So let's just multiple sheets for one. That's always good. And yeah, it kind of highlights some welding symbols. So we've got two parts. These are mild steel, solid round and plate. These are kind of undefined descriptions in some ways. It is solid round, I'm saying, and it's steel plate. But the reason why I've kind of like kept off some of the stuff that might be in a standard description is because this is a metric part, and maybe I'm building it in the USA, and so it's interesting that metric parts built in uh, internationally, they source metric sized materials, and so there is for sure materials that are sized differently than we buy them here in the States. And so I don't we don't really have probably our suppliers don't stock a lot of like metric size stuff. They stock our USA standard stuff that's like in that Pacific Steel manual that I'm referring to when I'm looking at steels. And so, but I can't. But even though maybe I'm a domestic manufacturer, I can still build metric parts with my domestically sourced materials. I just maybe have to be a little more creative. And so I'm kind of leaving that open there that I've got to determine what kind of parts are that I have or materials that I have available to me that I could make this out of. But it definitely could be made. And so this is something you would experience a lot, working here, but building metric parts is that it's going to be a little more expensive to continue, if I have a metric part to always source metric material sizes. So realistically, I can probably find a happy median and have our purchasers purchase the stuff domestically that can be made into this metric sizes that are required for this part. But you have to be careful with that because maybe some of your designs cannot be sourced or made out of domestically sourced materials, and we end up in a problem of, design doesn't I don't have the materials available to do my design, and so what do I have to do? Well, I have to maybe revisit the design and work with materials that I can get. So I've just left these kind of intentionally vague. They're just mild steel round. So what that a solid round means that this part here, one, I'm actually asking to be made. I'm gonna have to source something that's at least this big in diameter locally that is either solid or sometimes big heavy stuff like this, solid rounds that are kind of large in diameter. Um, they are sometimes they do have a hollow bore through them, and so I might be able to source something that does already have a hole through it. It might not be a finish hole, and my machinist can then continue to bore it out to my required diameters for the internal bore and the external bore. You just have to get creative sometimes and work with suppliers to identify, ooh, what can I get here? Now, and this, sometimes you don't realize that until you're almost ready to send drawings or whatever, and then you realize, oh my gosh, to even get that material, we have like a 4 week lead time, and it's good to it's hard to do, but later in your career you'll get better at like when you get issued, stuff to work with, you may have to also kind of be involved in lead times and getting materials here in time to do jobs, knowing that you're going to have quite a bit of engineering and design time way ahead of when manufacturing needs to happen. So the better you can be on that front end of sourcing stuff, working with purchasing, knowing that this design is coming, approvals have been sent off, we're ready to rock and roll. We better start looking for materials that we can do. And if we can't find materials, we better start redesigning, right? And so yeah, that's a real thing. And some drafters, put manufacturing in a bind when they haven't. Well, I blame engineering and drafting, project managers mostly, but they don't always know the individual designs you're working on in drafting. And so, you are responsible for, the designs they tell you to work on and the parts needed to build them. And that can vary from company to company. So let's see. So anyway, I'm thinking about this because it's a metric part and I live in the United States. What do I got to think about? But that's one thing that's going to be down, later in your career that you're going to have to worry about. Right now, let's just build it because we're, and so I'm going to build this part and I'm going to build a flange. So I'm going to build these two different parts. I view this as a flange and maybe I've called this thing like a flanged bushing is what I think I ended up calling this when I did it in class. And I think I'll continue with that. It's just kind of it is kind of what this represents is like a bushing of sorts, very common mechanical part that I'm looking at here. I've seen this in a lot of different assemblies doing different things. And so I don't know the in and outs of where this goes, but this looks, we're heading into definitely mechanical land here. So let's build these two parts. I do have these individual part sheets, which might be the most beneficial to draw these out. But so I'm going to go ahead and draw this part first. And I just drew it as a revolution. So I see this as a shaft, kind of a shaft-oriented part design. And so I'm going to just draw the profile of this, like half of it, and just do a revolution around an axis. So I'm kind of looking at so I'll pull these dimensions over. One thing that you'll notice is I've got like a stacked limits dimension going on here. So it's hard to understand, you might worry, what do I use here to draw this? I understand I need a dimension to make a hole here. Well, when I see this, I might look at and say, I'm gonna originally design it in the middle of those two dimensions. So my nominal size could be right in the middle of both of these. And in all reality, I could probably pick these two dimensions, one of them, and just run with it and get my design going, and knowing that I can just jump into it and quickly change a dimension to be the one that I actually need as I if I better understand the part later, right? So I could really choose either of these dimensions to use in my original sketch. I'm going to choose the dimension that's in between those two, and then I'm going to set my dimension up on my drawing to kind of capture these two options. So I view this as maybe a 22.5 nominal size with maybe 0.25 millimeter, just this bilateral tolerance, right? Yeah. Goes in both directions from 22.5. So I'll use that as my inner bore diameter. It's 44 in diameter that way, 41 right here, and I've got 52.38. So I'll just focus on this part first. Let's go make it. So I'll go into open up a new standard millimeter part. Let's get that thing drawn. So the other thing I'm going to kind of think about, especially if I'm working from somebody else's drawings or I get used to this, I'm going to draw this as my front view. So if I'm going to draw this and use the revolve command, I'm actually going to draw it kind of in its right side view, and then I'm not going to use the right side view on my drawing. I'm going to take a section of it like this. And so let's see. Yeah, so I'm going to think about my right side view is where I'm going to draw my profile. And then that way, when I drop this part on my sheet, it's just going to be front views set up for me. So if I'm thinking ahead just a little bit, here's my front view plane. Sometimes if it helps you like wonder, you can turn on these planes. I've I've just started to select my sketches, knowing once you select sketch, they all show up and it's easy to identify. But if you're just kind of exploring, like, well, this is going to be front view on my drawing per se. So if I'm going to do a profile of a shaft, I might use the right side view, which is really this plane here, your YZ plane that I'm going to draw on. And I'm going to sketch out the profile of that shaft and then revolve it around likely just this axis right here, this Z axis. So that's my plan. And so I'm going to go ahead and proceed with that. It's my YZ plane that I want to, oh, sorry, is that right? No, yeah, my YZ plane is what I want to draw on. So I'm going to do my sketch on my YZ plane. And so then, yeah, I've picked it. You can turn these off if they get annoying because they do want to be selected a lot to constrain to. So I can turn those off real quick. And I can just do just a quick sketch of this part is just comes up this way. And I'm looking for these constraints. There's horizontal, or sorry, it's horizontal in this plane because of just the orientation of my plane in relation to the two options I have, vertical and horizontal constraints. But I'm looking for these to show up. It comes this way so far, then it comes up this way. I'm looking for these to stay nice and perpendicular. I'm looking for those constraints to show up. And then I'm going this way for a ways, nice and perpendicular. Back down to here. Maybe I'll highlight this for a minute and use that snap tracking. Looking for it to show up right there. And then I'm going to close this off. So here's the profile of my shaft. with no dimensioning. So let's go ahead and do this. And I feel like you could do this a couple different ways. I'll do it like they've done in the book a couple times and kind of build in the center bore within the sketch here. But you could build it out fully like it's solid and then act like you're going to do another sketch to like remove from the end, like do a hole through it. Whether that's an extrusion cut or a hole, I'd probably use an extrusion cut to do that in the event that I revolve the entire solid without the hole in the middle. So you got to just be aware, how do you want to do this? Well, our book did it a couple different ways, using kind of an offset in between here and the revolution axis that we're going to revolve around. And so I think I'll do it that way too. And so I'm going to project the axis that I want to revolve around, which is going to be, I'm just highlighting through the origin type axis here. Not this one, not this one, this one. It's going to be the Z axis. I'm going to use that as the revolve. And then I'm going to space off this profile. So I'm kind of drawn from like here up, right? So this dimension from here to here is going to be half of this. But, I'm looking at this saying, what's that middle value between 0.75 and 0.25? Well, it's 22.5. So I'm going to say, 22.5, 11 and a quarter, but 22.5 divided by 2. Sorry, I typed 11. 22.5 divided by 2, right? 11 and a quarter is kind of would be the distance from the center to this top side of this inner bore. And then my shape that I'm actually drawing is right here. This is what the shape is. It's going to be revolved, not including this space here. So that's what I'm setting up. Let's see. So this particular dimension is from here to here. Is that 11 and a quarter? This is going to fold that almost like inverted it on itself, but not quite. You can just stretch these up because yeah, like that. And now I need to dimension this thing out. So some of this, now I can use this as kind of a base point to dimension, right? From center to the top, well, that's 44 divided in half. So that'd be 22. And then this is the shorter side of this is 41. So from center to where that starts is half of 41, 20 and a half. It's like 20 and a half. Then of course I have this little shoulder that I'll dimension from this way, 38 and 52. So I'm just going to pull this over up on my other screen and use those dimensions real quick while I draw. Kind of need to reference them. So I'm saying, from center to the very top of this would be half of 44. That's 22 millimeters. And from center to the top here, I'm selecting lines on most of these rather than endpoints, is going to be, if you selected both, as long as it's constrained right, it will be constrained. Even if I selected the endpoint of that line, because it's horizontally constrained, it would be constrained. But anyway, and this one was 20 and a half, because it's 41 in diameter on this end. But from here to here, it's just 20 and a half. And now my shape is kind of constrained, but it doesn't know these lengths yet, so let's establish those. So dimension, the overall between line to line here is my 52 millimeters. And then I'm going to dimension, from here, I could dimension just this, or I can say from here to here. It probably is fine. I'm just not doing to the midpoint. Let's see here, 38. So I've got that part. So you think it's all constrained. The only thing is it just doesn't know where that shape lives on this Z axis here. So let's constrain that. I think I'm just going to do like a horizontal constraint. Nope, I'm going to do a horizontal for a vertical, and I'm just going to look for the midpoint of this. And I think I'll just line up with this center point here. That's pretty well balanced that's totally constrained. And I'll just say finish. And this thing's ready to revolve. Use the revolve command. That's it. And then I just need to select the axis for it. It's this one here. I didn't turn it to construction material. I think I discussed this in class that it's just because that my projections don't crisscross my profile. And so that's when I usually get lazier between turning my projection lines into construction lines as if they're cutting across my profiles generally, and I don't want them to. So that's usually when I differentiate between leaving them solid versus turning them into construction. So I'll say that's it. That's my revolve axis right there. And then it revolves for me into the shape we need. And I'll just say, okay. That should be done as far as that part is, other than just like naming it that it's like a solid or steel, mild steel still, like that. I'll just leave the default semi-polished appearance. And I just need to name this, give it a description. So I'm just going to give it the same description that's in that other parts list. So this description here, I'll just say is maybe it says mild steel. I'll just say MS solid round. So maybe somebody at some point I looked in and found that, hey, I can't source this with a through hole in it. I can only make this solid round. And so I'm just gonna have you buy a big enough diameter to be able to machine that bore and all these surfaces to true them up. I'm gonna have enough material to cut from it, kind of do a subtractive machining process to get this down to its actual size. So everything has to be a little bit bigger. And so I'm gonna just make the machinist have to bore that hole out. So I'm gonna say okay. I'm not gonna worry about updating anything else, just that, just the description. I just need to save it as my I think I'm still in week 4 on my parts because I have my 15.8 part one. Yeah, so let's do. I've already done this, but I'm gonna say that this one's my part one. It's the first one I drew. Save it. Yes, I'm overriding that other one. Cool. Let's make part two. However, not part two in my video. Continuing on, I'm going to make this flange now. So I've got kind of the bushing part of this or some kind of a sleeve, shaft sleeve, something. Here's the flanged part that'll push that into position where it goes. And so this thing is what, in 100 millimeter in diameter, the 41 millimeter inner bore. And this makes me a little nervous because I know that I just made this 41 millimeters in diameter, and those two do slide together. So I may have to increase some. I may have like what it makes me think is this thing probably needs to be toleranced in order to always allow it to slip over this. However, I didn't design this, so I don't know the intention of this part. Is it going to be an interference fit or is it going to be a clearance fit? It's a welded connection, and a lot of those times those are when we have welded parts, we definitely probably we de it can depend, but we can sometimes. Well, there's no rule of thumb here. It's just you have to know, but this could be one that just slips over. So clearance would be better, so that the welding fabricator, the machinist might do some initial welding or machining on this to where the welder can slip that flange over, weld it all out, and then maybe deliver it back to machining for finished machining after welding. And so if that's the case, this thing might need to be bigger than 41 millimeters to slip over easy and allow the welder to place it on there pretty easily, do the welds, and then hand it back off. It could be that actually, no, we're going to press those together and then still weld them afterwards. So there's still, I think, there's going to be a tolerance associated with that as well. So this isn't totally adequate to me, but let's move on. And let's build that part. 100 millimeter, 41 millimeter, and then it's got a 70 millimeter bolt circle for the counter bore holes, which here's their call out on those. So in this case, I'm already planning on, I'm going to build this as just an extruded part. I'm going to place a point. I'm going to perform the whole features for that one counter bore hole, and then I'm just going to pattern that around my part. That's how I'm going to proceed on this one. But there's different ways you could do that. So let's do it. Let's do my new part, a new standard part right here. So pretty much the same. And this one here, I'm gonna build it on the XY plane. And just because I can already tell that this is the front view, and I'm going to section the front view here as well. And so this is just going to be my front view XY plane of this part. So I can pretty much say I'm going to start my sketch on the XY front plane, right? Yeah, this one. It's going to ease up my drawing a little bit. And especially since I have total control over that, I'm not dedicated to something else. So I can pick. So I'm just going to do some circles here, right? I'm going to drive them by the center. So they're going to be constrained. Once I enter a dimension, they'll be constrained because I'm snapping center to origin. I needed 100 millimeter diameter for the main diameter. And then I'm still in the circle command, so I can just do another one. Snap here. And then the next one is 41 in diameter for the inner bore, which is the one I have a little bit of an issue with, but that's all right. 41, and then I have a bolt circle that's at 70. So I'm going to add that one while I'm in here. And then that one's just going to be construction for sure, because I'm just using it to drive the location of the counterboard holes. So really, this is it. You know, sometimes I do my work so I can see these clearly and get into the sketch and edit them pretty fast. And let's see. So I'm gonna plan on using the whole command for my counterboard. It's definitely the go-to way for that. Especially because your sheets will pick up those whole notes. You know, if you use the whole command, it can make the drafting side of it easier because it's a selectable feature that is the templates will auto-populate the counterbore diameter and depth and the through hole diameter for us. So we don't have to actually do that as individual like line items on my drawing if I drive it this way. So I'm going to place a point on this. Really, I want it to be like right here and stay in line here, but I don't really have a constraint this way. I'm going to constrain to this bolt circle construction line though right here. But the reason why it's purple, if I zoom out, it's sometimes easier to see, is because it is constrained to that line, but it's not constrained in this direction, left or right. So yes, it'll stay on that diameter, but I need to have some type of geometry to constrain it to. So I think I'm going to just project one of the origin planes or axes here, but I think I'll just use this plane here, this one. And that one cuts through my profile that I'm going to extrude. So I think I will just go ahead and turn this to construction. And then I'm going to constrain that with a coincident constraint, this point to this line. And now that thing is constrained in space and won't move on me unawares. So that's it. This is my sketch. I think I can finish this part like this. So what I need to do is an extrusion, and I need to know the thickness of that extrusion. Default's going to be 10 millimeter. There's my profile. So I'll jump back over to my sheet here that I'm using. It's kind of an odd, I mean, this isn't something I know off the top of my head. What's 7.8 millimeters? I don't know how thick that is really. But that's what I'm just going to enter 7.8. This is another reason why, I have to be aware, can I get this thick of plates? I'm going to cut this out of probably sheet or plate. I mean, this is getting like, how thick is this? Well, it gets into plate if it's above quarter inch. So you need to know like a conversion or pull up a converter on, I use my calculator a lot, but I like to be aware of like millimeter conversions to my inch units that I'm a little more familiar with because I've been living in the United States. So 7.8 millimeter, I like to multiply by like how many millimeters, 7.8 millimeters times by, there's 0.03937, 0.03937 inches in 1 millimeter. So it's a little bit more than a 32nd. So if I multiply by here, this is the I mean, I'm only telling you this because this would be if I'm worried about sourcing the thickness of sheet that would be available to do this or plate. This is zero point 0.3, so I'm into plates land. So I'm gonna have to source a plate that's at least that thick. And if this is a truly like, uniform machine part, high criticality on maybe the faces of this flange, how it bolts up to something, then it's likely that I'll select a sheet size or plate size in this case that is thicker than I need and have the machinist face this flange off to be like super flat if it's necessary. I mean, that's additional cost and labor. And obviously I'm gonna have to do some machining on it because I probably don't have a stock sheet on the rack in the USA that's 7.8 millimeter perfect. And if it's a critical application, the machinists and welders wouldn't want me to source that anyway. They would want to face this off. So it's probably a more expensive part for sure. Because I'm going to have to source something that gives the machinists and welders enough, specifically the machinists, enough material to cut it flat and face it off. And by face off, I mean they're going to like cut this with a tool that will cut this and face off this surface. And so I'm gonna talk to my purchaser and say, I gotta have something thicker than this. 5/16 plates, 0.3125. 5/16 plates probably readily available, but it's a little bit of an oddball size. Next up from 5/16 is 3/8, 0.375. Well, that's plenty big. Is it too much for my machinist to cut off? Would they rather have the 5/16? I don't know. These are things designers worry about. So let's go ahead and your engineers and project managers They are so happy when you can kind of figure out some of that stuff and what to make stuff out of or have that discussion. But it takes experience. So let's do, yeah, I'm just going to extrude it 7.8. So I'm going to make it actual size, but it's an oddball size in America. Let's see. And then I'm going to use my sketch to put the through hole. I'm going to use my hole command to do the counterbore, which is on that point. So if I extrude this way, I'm gonna have to come and put my counterbore on this side, which is technically the back side of my part. Really, in my drawing, the front side is carrying the counterbore. So therefore, for me, I'm going to push this way, extrude it away from my sketch. I'm not going to extrude it in between because that would bury my point in my solid, and so it would change if that whole command is going to do, place that feature how I want it through my part. So this one I'm being strategic and saying, because my sketch location and what I'm going to do after this is I'm going to extrude it this way strategically, and then I am going to turn back on my sketch and use it for another feature here for the hole. So yeah, there's my part. Great. Here's my sketch that has my point for my hole. And so there it is. It's going to last default was just a through hole. So I'm going to do a counter bore right here. And I'm not going to change it to a clearance hole or a tapped hole, or it doesn't even give me the option for a taper tapped. But I'm just going to do a hole. And then I had come down here. I'm going to do, how am I going to terminate it? Well, I do want it to go through all. This is one that I like to use. If you don't, you get more selections here to go through how far this goes. Is it a blind hole that has some finish depth requirements, or is it going through all the way? So it complicates it a little more. This simplifies it for what I need. I do need it to go all the way through, and then I can select the sizes of the counter bore. So I believe this one is got to be checked for me. It's 7 millimeter through. It's 12 millimeter counter bore. That's what this symbol means, counter bore. And its depth is 3. So that's 7, 12, and 3 is what I need to know. So the counter bore is 12. Its depth is 3. It'll apply the units for you, so I don't even worry about typing mm in there, even though they show up. It's 12, it's 3, and this is 7 in diameter here. So this big old counter bore is done. On center, front view, just like that's how it's going to show up on my drawing. It's, I can change the orientation on my drawing like we do, but right now I'm kind of setting myself up for success on my drawing. And I think I'm done with this sketch as far as what I need it for features of size. So let's do a pattern now. I'm just going to do a circular pattern. Since this is a separate feature on this extrusion, I can select it as a feature here. Bam, that's counterbore feature. I can select the rotation axis. I don't have a sketch necessarily. I think I could just even pick a solid like this. I sometimes get in the habit of using my origin planes, maybe, and then the default is 6, which I'll change to 4, and it'll put them in my location that I need. So there's simply that. The rotational direction in my case doesn't matter, but sometimes I can change that rotational direction if I have maybe an incomplete or a kind of a different hole pattern. This is really customizable, so I'll just say okay. There's my 4 parts on and or sorry, there's my 4 holes, counterbores, and I just need to fill out the rest. It's going to be steel plate, right, or just mild steel. Carbon steel is mild steel. So there's some redundancy in that materials list, but just mild steel works for me. And the description on this, I think I just said mild steel plate, right? Is that what I said? I'm gonna update that before I go. Sorry, it's up here on this one. Just mild steel plate. MS plate is what I'm gonna put in. Some type of a description. Every part needs a description. Mild steel plate. Okay. Save it as my next part in my series of it's part 1 in class. Yes, save it. Yep, I want to replace it. Let's do an assembly. Weldment. Nancy millimeter weldment. Create it. Let's place some parts. I know I'm on my weld tab. Let's move over. Place. I need 2 parts. I need a 18-1 part. Just need one of those. So I'll say that's done with that one, and I'm going to place the next part. It's 18.2 in class. Yeah, that one. All right. I'm gonna ground and root this one, and then slip the go ahead and then I'll slip the flange onto this little bushing here. So let's do ground and root this part. I'm gonna say okay. So that's on the origin point. That way this thing is going to be super perpendicular to my front view plane. If you're getting stuff like your assemblies dropped on your prints and they're not in like perfect orthographic alignment with that view plane, it's because you're not constrained in the assembly. Um, you haven't constrained it in the assembly to those view planes, right? That's really critical for sure. Grounding routing takes care of that for me, but it's not the only way. I could like orient all the planes and do my own. This just does it in one step, but I could just do constraints on that to the some type of origin plane, but I've definitely got to get it for our drafting purposes, I've got to get it in orthographic alignment, I feel like, to this view cube. So pay attention to that and watch out. And then, so this one's fixed, and I'm just going to place this one over it. So I showed you like a new constraint in class, and I'll use it again. We're going to constrain this thing, and I could do face to face, face to axis to face. Like I could walk through all those. I kind of would need to constrain it in three directions, right? Like a face to a face, and maybe or to a bore, and then I've got to keep the flange hole pattern in the correct alignment in the front view, so the holes are located correctly. So I use this insert command for fasteners a lot, but also for applications like this, where this just slips over that. And here's my insert command. What it does is it's kind of doing a compound command. It's going to do I get to kind of pick the axis that I want to align, but with relationship to a face or an edge of a face. And so in this case, I'm going to say I want this edge to really seat against this edge here, right? Or at least this edge. These are kind of on the same plane. And so my first selection is going to be, well, this one, but you'll notice it's picking up the axis too. So I want this one, which also includes its axis, to be constrained to selection two is either going to be this one or this one, but these are where they're going to, I mean, technically, I guess that one's going to join this one, but in this case, you could select either, but that kind of incorporates that edge and the face of that edge with that axis here. So when I do this, they'll snap together as almost, it's doing compound constraints in one in some ways. And so that works for me. I like that. So I can just say apply that constraint. And then if I just step out of this for just a minute, what it does, which sometimes doesn't matter on fasteners, but what it allows you to do is quickly place a fastener and maybe move on. But the reality is there is still 1 degree of freedom here that needs to be locked in, especially in this case where it's a flange. This thing can spin. And so I have this rotation, and I want to control that so it doesn't just come into like in my front view. I don't want it to look like that. I need it to look straight up and down. So I'm going to do a plane alignment here just to lock it into position so that my holes are in the correct location. You would think like it doesn't matter, and you're kind of right. It doesn't matter. It just matters for my dimensioning and getting it like squared up on my drawing. And it really does matter in real life, but technically, the person can just like rotate this and install it, and they wouldn't even know necessarily if they're going to put this on, it's going to work just fine. But in my drawing, it's not unless I really constrain that thing to be how it looks in the front view. I need to not look crooked like this. And so, and some parts it really does matter. I normally would have to constrain this, even if it doesn't matter, but it does. It matters almost in every circumstance. So let's do constraint. And I'm going to expand these parts and their origins. So I'm gonna use part to part origins rather than actually the invent or assembly origin, which is up here above all my parts and above my preps and welds. Like here's the master assembly origin planes, which technically this one's ground and rooted to those planes. So they do already this set of model planes or part planes here really already align with this. And when I'm thinking of this flange and what to constrain it to, I'm really constraining it to this other part, right? And so, I think of that. I do try to not just use I do think of when I'm actually joining them like I actually would in real life. Let's use the geometry from those two parts together a lot of times. The only exception to that usually is for me is maybe I'll use the master origin planes at times as well. So I definitely do some different things, but what I'm looking for is just two. You have two options really, because I'm looking for a plane and plane lineup. So this is not a great option. I've already technically like used this as a constraint, not this plane, but I've used my insert and the face planes to align. So really, I could either use this plane and then find it's the opposite one or the same one on the other part, or I could use this one and find that same one on the other part. So I'll say I'm going to constrain, let's say this YZ plane, and I don't even worry about the name so much. I'm actually a visual person, so I actually am just like scrolling over this and saying, oh, is it the YZ plane? Well, technically it is. Like they are the same plane that I could line up, but this, technically this one would work and my part would spin 90 degrees and align that. And it might be in a different orientation than I did the sketching in the part, but theoretically, does it matter which hole's up or down? They're the same holes. Um, you just have to be careful, I guess. That's gonna work though. I just actually picked these two together. I don't know if this is the hole that necessarily has my sketch and the original point, or if it's this one down here. I don't know. Maybe it's this one. This is gonna work though. I'm gonna say okay. And now this thing can't spin. And when I look at the front view, if I toggle that on, this is how it's gonna show up on my drawing. So now we're ready to do welds. And so I discussed in class that I could. So let's just look at the welds and what I've got to do. I've got to do some prep for them. I'll zoom in a little bit here on my. I've definitely got a weld kind of like a arrow another side, but we kind of talked about this in class. So a lot of times when you're looking at like a pipe or this round cylindrical shaped feature, and we point to like even a flange weld, this could be interpreted as like, yeah, I'm pointing to an outside weld essentially, and it's the arrow side, and the other side of this could technically be maybe the inside in some situations. Like that wouldn't make total sense here because the part is really only on the outside. And so really, I'm on the fence. I could do these as individual arrow side. Um, I'm doing this as arrow side weld symbols, but I do think you could definitely put the weld symbol here for the bevel groove weld, and then you could maybe other side this, put the fillet weld, and the welder would interpret this is the arrow side, this is the other side, because technically there's not an inside because this part doesn't doesn't yeah, it doesn't make sense that that would be there would be an inside weld joint where this part only goes around the outside. So that's how I'd maybe interpret inside other side, or sorry, arrow side other side. Now it's different when I am like, and where we discuss this in class a little bit is I actually had like a round feature, and we'll do this on the next assignment next week on the pipe support. We'll actually, instead of being kind of a configuration like this, we have a plate that's slapped on the end. And so the way the two parts work together, the plate on the end for like a mounting plate on the end, and I point to that. It's going to confuse you a little bit, but then that would be arrow side. Other side would maybe be the inside of the pipe where the plate meets the inside of the pipe, and that's almost that's an impossible weld to get into on small bore pipe. And so that one could the weld symbol could be anyway. I'm over explaining a little bit, but I am now on the team that these two could be combined into one weld symbol. This could be other side, this could be arrow side, or this could be arrow side, and this could be the other side. So, and I guess when in doubt, just individually call them out. When in doubt, individually call them out. That's another rhyme there. And because this keeps you safe, I'm pointing to both. I don't necessarily want to make the mistake here, so I'm just going to do two arrow side call outs, safety, right? Okay. And so maybe I'll replicate this, but I definitely think you could do an arrow side on the other side on this. All right. Let's do those welds. So this, if I'm going to do the bevel weld, we discussed this kind of in length in class when I made this originally, but yeah, it's a single bevel I call it all the time, but just a bevel weld. Looks like the beveling is going to be done on the flanged plate. The depth of the bevel or the size of the weld, how deep I'm going to weld into that is going to be 4.5 millimeters. This is 7.8 millimeters, so I'm not going all the way to the point here. I'm just going 4.5 millimeters from this kind of face surface down in here at a 40 degree, all cut out of the flange. And then it's going to be ground flush. Is it going to be machine flush? Maybe it should be. I think we discussed that too, that this is kind of a difficult thing to grind flush and not like chew up some of the, with a grinder, it's definitely the most manual process done by hand generally. And that might be detrimental to this, the finish of this outside bore here and the this back side of this flange here. That looks to me like it's going to be a real critical alignment in this part, just based off the counterbore and how things. I have a feeling that this is going to seat up against something, and this is going to be a bolt. This is going to be a fastener bolting into something. And so I feel like, the relationship of this being 90 degrees and these surfaces being really good and probably likely machine finish better. That's so grind finish is a little bit sounds a little bit rough to just grind my weld flush here and have potentially chewed into this. Be okay if the mating surface is like not where the weld is, and so it's not, I mean, it could happen this way. And then I have a fillet weld other side that's 4 millimeter leg length. And the all around symbol is nice because it is a weld that goes continuously around this part. I think I could probably drop it and it would be understood that it is continuous weld unless I called out a intermittent length and a pitch and a length. Otherwise than that, I would understand it to be continuous based on the nature of the parts. So this might be maybe unnecessary, but I'll add it too. So let's do the miter bevel 44.5. And we kind of talked about this in kind of detail. So this is a prep phase of my weldment. So I'll go over to the weld tab and go into the prep tab, which I have access to sketching. So this I could do this a number of ways. I could like maybe pick a sketch to do on this like center axis right here and get in there and sketch that little profile of that cut and then cut that around. Yeah, this is that would be a way to do it, to do a sketch on that plane that's perfectly perpendicular along that center, and then to do a radial like cut. But I think I'm going to do what I did in class, which was a chamfer, but it additionally complicates this. So what I'm trying to chamfer is this like edge of this part that now I've slammed into this part, and I can't hardly even get to that edge. Like I could select it, I could turn it onto wireframe or whatever. I do it a little differently. I can be like, well, I'm going to turn this visibility off, and that one becomes this little wireframe icon over on your model browser. But now I can get right into the part. This is the edge that I need to chamfer, and so I can do my chamfer command, and it wants to know edges. And it's going like default's usually going to be, the equal distance chamfer. Well, that's not the case here. Equal distance chamfer, if it would be 45 degree, and ours is 40. So I can't really use this one. I need to use a distance and an angle. And so my distance is actually the depth of my well. That's how much I'm going to bevel into this thing, and that's 4.5. And the angle is the bevel angle that was called out in the weld symbol is a 40-degree bevel angle. Now this complicates this because this is technically going to become an unequal leg chamfer, like this one would be. I'm just driving by distance and angle. And so when I select face, this matters which one I do. And so I'll do both, or I'll do it maybe wrong, and then I'll say, oh, that's wrong. Let's do it right. So what I would do is like I need to select a face. It's going to be 40 degrees from this face. And so if you chose this face, and then you chose this edge, because that's the next selection is edge, and it automatically moved me that selection. Then it's showing me that this is what's going to cut in there on this chamfer. And if I said okay, then I would wonder, am I correct? And I would need to figure out the measurement. But if I understand the weld symbol correctly, the weld needs to be 4.5 millimeters deep. And so this needs to be from that face 4.5 millimeters deep. And so if I can measure that real quick, measure, right click measure from this face to maybe I'm just going to select this edge. It'll give me this like nice linear length here if I look at my end view. See, this is 3.77. So technically by selecting that face, I'm not beveling the right way. I'm not getting the depth of the bevel how I want it to be. So that's the incorrect face to incorrect face to select just based off my test measurement there. And so the other thing is I'm in the prep tab. It's the only thing I have access to over here. I did find that that's not re for whatever reason. I don't think I can reselect that face. If I go in here to edit that chamfer, I should be able to maybe redo these. Maybe if I yeah if I maybe if I do that, if I just jog these back and forth and almost come back in like I'm selecting new. Maybe let's see. I think that's it. Yeah. So I'm going to select. Oh, no. What it does is it keeps that old chamfer kind of. Maybe let me just see. I would select that, but then my edge, I don't have it because it's like that old chamfer is still there. So, and it's probably just that I'm doing something wrong here and I should be able to preserve. Maybe if I collect preserve features. No, see that dang chamfer just stays there once you've put it in there. It's unusual to me, and it's not that I remember that, but it's actually like I'm going to delete this thing because it just didn't turn out to be the way I want, and I'm going to redo it. I'm going to do this chamfer. It's going to be an unequal leg. Those are my measurements I want, but instead of I'm going to use this inner bore as the face. That is a a round face, but it's a face, and this is still the same edge as long as I haven't flipped my part over, but it is the edge opposite the counter bore that I'm looking for. And so now if I bevel this way based off that edge, that makes sense too, because that's the 40-degree included angle kind of from right there. So if I say okay on this and just do a quick, I wonder if I unselect preserve features before I made one, if that would actually not show up. Oh yeah, it makes me kind of want to test that. But either way, this is how I'm gonna just undo that real quick just to see this. Like if I went into a new prep, that is the correct way, by the way, but this face, what if I uncheck this real quick? This face, this edge, say okay. That's my normal prep. That's the way we want it. If I measure this out, face to edge, 4.5 millimeter. That one makes sense now. So now I've selected the correct face to base off the depth and the angle that I'm chopping that miter. So that is correct weld prep. Now I'm slightly wondering, could I have made if I select preserve features, what if I do this? Now it still stays in there. Weird. It's okay. I don't It's okay. I probably should have kept that selected on instead, but I was thinking it maybe would allow it to just like jump back to no chamfer. It's kind of strange. So it could just be a function of how chamfer works in the weld tab on the preparation tab. That could be it's just how that is set up. But that's the only prep we need on this part. So I'm going to return and I'm going to go ahead and turn back on my missing part, which I selected back here over the model tree. It's the 2D wireframe looking icon. And I'm just going to say visibility, check that on. So that's actually the part prep to weld. And what I've discussed in class is that this is unusual. I'd want that shoulder out of my way here, potentially to have the welder reach down in there. They could complain about this weld joint isn't prepped in order for them to access how they want to weld, because it would just be hard to get any kind of fusion on the face of that shoulder is going to be kind of incorporated into the weld, but the welder is going to weld it where they can reach here, down in here, and do multiple passes potentially. And this corner of this just in my way. So I know this is like a weld. I could correct this in some year. I probably will because I feel like I know this is kind of an assignment out of the book actually, but I feel like I'm setting my welder up for some difficulty here. So I'm gonna get some revision feedback on this. I'm not gonna like it probably. But if I knocked the corner off this, that would allow the welder access to kind of like fuse in all these surfaces together and not necessarily leave a cavity or a void in there that would be X-rayed and be potentially like not good adhesion just based off I can't weld around corners necessarily in this particular. Yeah, it's just difficult. I left it though in class just because I wasn't making that change this year, but that's the weld prep there. Let's do the weld that goes in there. So it's just so I'm going to switch over to weld. It's going to be a groove weld. This is a bevel groove weld. So I have these faces. What I'm really welding together is kind of this face of that part. And the second face set's going to be that bevel that I put on, or that chamfer. And then this is going to be radial filled because I'm around, and then that looks like it works just fine. I'm just going to say okay. And then I'll change this. This probably is going to be aluminum as well, so I'll change this to steel, welded steel. Sorry, I'll change it to welded steel. Sure, gives a little bit more of a contour or a texture finish, actually. Okay, so that's kind of what that would need to finish like, and even be ground smooth, right? This is what I mean. It needs to be ground smooth, but this is going to be hard to grind without like nicking this with my grinding disc and like scoring it or damaging it. Maybe it doesn't affect the mating seating surface though, so maybe that's already been incorporated, and that's just the cheapest way to get it low down and dirty, so that something doesn't, ride up and hit something. But yeah, a machinist could cut this cleaner and more professional than a grinder could. And the welder would be required to like overfill that a little bit and make sure you don't underfill that weld so that the machinist has material to cut off. And it almost makes the weld disappear from the human eye would be able to see that that's welded necessarily if it's done and cut clean by a machinist. So the next weld is a fillet weld on this side. So it's just going to be a fillet weld that's 4 millimeters. And so here's my fillet weld, and it's going to be 4 millimeter leg length. I'm just going to enter one. Um, it's an equal leg, so I think I can just enter one value. And I just need to pick those surfaces. So I want this surface again on that shaft, that bushing to weld to this face here is where my welder is going to put that, like just like that. And then I'll just leave it as a nice flat finish and I'll say okay. And that's my second weld. And I think that's welded steel, yes. And so this thing I just named, so this is done. This thing is ready for print. So I'll say return. My welds are done. I need to call out those weld symbols and place this on my drawing. I'm going to make one quick little eye properties adjustment. This is an assembly, so I can just think of, well, what's the description? I called it a flange bushing like this. I'm gonna say okay. I just gave it a name, something that'll show up on my drawing. It's a flange bushing. Okay, let's put it on a drawing. So I'm gonna go ahead and open that up. It's a metric template. I'm gonna go ahead and save this. Sorry, save this as my new drawing name. Need to replace that one because I'm working from fresh here. So this one ends up being like a multiple sheet drawing. So it's pretty common that my templates are just a single sheet. So I'm going to go ahead and make a duplicate sheet right now. So just create a copy of that sheet over on this browser and just go ahead and paste these. Select back out here and I'll just paste them. I could continue to do that. It's pretty common for me to like make multiple copies, and then I'll jump over here to this, and then I always have like one fresh, untouched copy that I can always make a copy of. So, you might see me like make on a real drawing sheet, maybe I'm anticipating. I don't know how many sheets I need, but I might make 5 copies right off the get-go. And then once I get 4 of them filled up, I'll make 5 more new copies and fill 4 more or 5 more of those up. And always have maybe my last one being like a nice fresh sheet, so I don't have to delete a bunch of stuff off it. It's not the end of the world, but then at the end of my drawing, I wouldn't want to include a blank sheet in my drawing sheet set, so I would to make sure to delete any blank. Like if you were anticipating needing more sheets for your drawing, you could just finally at the end delete the blank one. So and then let's I don't think I actually saved this particular assembly because it doesn't have a unique name here. So this is my assemblies. Let's do this one as one in class. Save it. Yes, replace it. And so I've got my drawing ready to go. Maybe I'll slide it over here. Oh, sorry. I just kind of lock that in. Sometimes it's funny. I look for that blue. There it is. There's my drawing. Here's a part. Here's a part. I'm going to just jump over here and slide my assembly over here. You don't have to do this. I just kind of like to keep track of my parts, drawings, assemblies, parts. And then I'm going to look at it, jump over, base view it. That's the view I want, and I want one orthographic view, and then I need a section view. I don't need a top view. I need my view label. Let's go. Got it. Yeah, there's stuff showing up there. That's great. I'm going to do a section view. We're going to do parts list. Let's go ahead and get this started, and then I'll leave it for you guys to finish out based off my uploaded drawing sheets. But I want to get the BOM for this, get my bill of materials. Those are my two parts that I've designated for this assembly. Just clean this up a little bit. And let's go ahead and do a balloon. That part's number one. Maybe this part's number two. So those are my two parts. I need a section view and I need weld symbols. Oh, I definitely the best place to see the welds. I do have my hidden lines on here and just picking up the back shoulder. I think I ended up turning that off, especially because I have a weldment and it kind of shows. But normally we'd probably leave those on. Um, and I don't think I toggled them off in my video that messed up on me. But let's see this one. So I'm going to do a section view. Let's go ahead and do that then. Place my views, section view, because I find that the section view exposes my welds easier to. So I'm going to do this view, select that view, and then I'm going to just object snap track up here, down through, right nice through center is what I'm looking for. Nice perpendicular alignment here. And then that's the only thing I need right there like that. Perfect. I'll place it over here. So there's my section view now. And this just exposed my welds so I can point them out really good. Not that we would always do a weldment and I could just point to those, but I would love a section view of this to actually still call out the welds, even if they weren't shown and they were just the assembly and how they go together. But so let's do those weld symbols. And I'll do them separate again. That's fine. We can do it. So this weld right here, just point to it, grab a point on it, come away a little bit. Let's do a new preset or no preset here. This is going to be an arrow side weld. I'm pointing to the side the weld's on. It's a bevel weld. So let's first establish my bevel, single bevel weld, bevel groove weld. It's not like an actual size that I'm evaluating this with. It's really just that kind of theoretical size and how deep the prep was. So it's a 4.5 size weld deep into there. And we are at no gap here, or no, sorry, I'll move this over so we can see it as it builds it. 4.5 bevel groove. No root opening, but I did have a 40 degree bevel. I'm not doing intermittent welds or anything, but I did need to grind it flush, and that's over in this little extra dialog box, the contour. It is a flushed ground. Got concave, convex, and flush ground, and it's ground. So this next box, I think, just showed up. Yeah, just showed up after I did that. And these are all just, you'd have to look these up. Probably won't memorize these, but the way I finish welds, I have some options, and I think I can at least name the U and the R. I can't remember these all the time either. I just know that I see C for chipping is common with when weld beads have slag on them, and which is a flux coated welding electrode. G is going to be for grinding, and H is for hammering, and M is machining. I think they're in our book. I'll have to look them up. They might be in surface. I'm not sure which chapter they're in. I'll have to look. So G for grinding is what we want though. And then we need a tail because we're going to say this is SMAW. And I think we even added the all around, which is debatable, but that's all add it here all the way around and say okay. And then do another one. This is going to be an arrow side weld as well, but I'm just going to say no preset because it's not related to this other one. Um, so I'll just cover this one up and look at this weld symbol here. So it's going to be arrow side fillet weld, yes. And I've got my two leg lengths. I'll just put in leg length 1 that it's 4, and that will be sufficient that it's an equal leg weld. 4. It's not intermittent, but it is all the way around. The same process, right? SMAW, shielded metal arc welding. And no finish profile, or we're just going to weld that and leave it. It does have slag on it. You'd think we would tell them to chip it off, but it is, I think, generally understood. No welds generally get left with slag on them. But stranger things have happened if it wasn't called out on a print, I guess. I think this is sufficient for what I did with for what we did with this one, yes. So I'm going to call those my weld symbols. Say okay. I got two arrow side weld symbols. I'm going to go ahead and escape. That's all I'm going to apply there. If I just look, there's a few more things I just want to point out before I just let you take off. Yeah, you have another, um, the other stuff that's on this page here. Zoom out just a little bit here. So I've got those. This just kind of has a few general dimensions. They're not, it's not like it's not like I've repeated every dimension that's on the part sheet. Like this one definitely contains the, the size and features and the size and location of features in my front and section view. I like that it will be better with our new template that it'll actually say the part. It'll have the part number here as the view, and that'll directly relate to what's the part number that's in your list right here. So it's easy to identify. Currently, this is horrible to identify, especially on a real complicated assembly. View 11 is not going to be sufficient to know what the heck part is view 11 showing. I don't know. What if I had 10 more of these that are slightly different sizes? That's a problem. So it really needed to be updated to populate that part number, just like this one populated or my new one populated it. So it should, maybe I'll place one just to make sure everything's working right, but should populate my part number now instead of a view name. And, but, so I really definitely cover all of its necessary dimensions here. Have a bolt circle, I have a call out for what's going on there. I have some thicknesses, overall sizes, diameters in the rectangular view, location, four of those. One thing I might see is I could dimension from center to one of these and have that kind of track that from center 41 is 22 and a half from center. So I could see adding a few more dimensions that we've normally added even here to the first. It can be helpful. Maybe it's common to start dropping that, and it's just generally understood that this 41 is over center, this 100 is over center. Uh, and so I've kind of dropped some of the stuff we were doing. Yeah. Let's see. I need to show you how to do that limit, but I can do that up here. So I've included some of those dimensions, but not all of them, especially the ones that are associated with the assembly, though. The 6.2 and arguably maybe not the 7.8, but for sure the 6.2 needs to be, it's the only place that exists is on the assembly. It's not, I don't know what that dimension should end up being, like a checkable dimension that's seated down right and that everything was built right. This dimension maybe is a controlling dimension, and so it doesn't exist here, right? So it has to be in the assembly. So a few things are required. Some things are a little bit redundant, but I like overalls on my assembly drawings, just sparse enough. That's where the welds need to be called out. So really, that's what this master here, and I don't have the redundant like call out on these because it's captured on the actual part. So there are some things I've dropped. Some of these I could probably drop, but I've just included a few extra dimensions. So I could refine that a little bit and say, wow, just pull that off. Maybe just show the 100 and the 52 and the 6.2 and leave everything else off dimensionally. Leave that off, leave that off. It's on the part. And then put the weld symbol. So I could simplify the dimensioning a little bit. I'm okay if we just recreate this though. Um, it's always that refinement process you go through with your prints and determine what's absolutely necessary. But so I'll deal with this one because you need to know how to kind of work with that one. And I'll show you how to do the polar center line too. So that's something I forgot maybe in class to show. So let's go over here and do a few things. For sure, I need center lines. Those are often forgot. So I definitely want this one between here and here. I'm using that center line command to apply this. I think it's probably a little short of ASME standard, which would be 10 millimeter through there. Wait, it would be 6 millimeter through there off the side because it's a quarter inch and inch in inch templates. Our center lines extend past their object's quarter inch. In metric drawings, it's 6 millimeter is the equivalent of quarter inch. Is that right? Yeah, yeah. So I just kind of eyeballed mine, but that's one. Then this dimension that went in here, this dimension from here to here is going to spit out. Oh, and the other thing I've updated, and I think I've mentioned this in some of my videos, is that this first like I did set that this will be 10 millimeter. That first little thing that shows up is 10 millimeter. And then these next ones are 6 millimeter thereafter. So every one of these are 6 millimeters away there. So I would come away to that first one for my 10 millimeter spacing. That was something I set up in the template as well. And then I'm just yeah, I'll go ahead and leave this as those tolerances. Let's see, what was I going to do here? Oh, but not that. No, let me go back into that. Double click to get back into that same menu. Sorry. Um, I want to go over to the precision and tolerance tab. And instead of doing just my default or just showing the displayed or model value here, I'm actually saying I'm going to do a limit stack. That's the kind of dimension that's showing up there. It shows the limits of that. It has to be at least 22. 0.25 and 22.75, and I've modeled at 22.5. And so really you have the option to enter the upper and lower kind of stacked dimension. And so for upper value is going to be the largest hole size on a hole. Upper value on a shaft would be the largest diameter. But so this upper value is going to be 275, and the lower value would be my smallest hole size. So I got an extra decimal in there. 22.25. I'm going to say okay. And that's how that dimension was actually applied. Gives me that stacked limit dimension. Not that I've chosen that. It's recreating assignment, but some of this I could think about refining. Okay, so the next one is going to be, let's see, I feel like I'm going to add a center mark to just the overall like this through. Which kind of captures quite a few of my intersecting lines through my holes and my. So I'm going to apply that one, but then the polar. This is the polar center line is what's pulling through all here, and so that's what this one is. So I think we've used most of these. Maybe we haven't used just a normal center line, but that one could be used. But it's just a line. This one's going to allow us to do a polar, a centered pattern like it shows there. Is kind of what I'm trying to recreate. So I select that. Command line down here, low left says select center of circular pattern. So that's, when in doubt in a command, check that lower line. Maybe it gives you some hints about what to start with because you might select here. This is actually where the center of the pattern is based, which is the center of part here. The bolt circle goes around this axis. So I'm going to select that. Then it says click on location. So this is unusual, but it says click on location. Well, these features are what I'm trying to do. So it's like, I'm going to just select this outer one and that shows up. But then if I select this one, now I get this tracking through it. So it's actually just kind of let me pick these up in a series. And then what's frustrating is you have to remember to click again where you want to terminate and then right click and say create. So it's a bit of a clicky process to get that established, but that's what I use for my polar center lines. And I put one on here, but I didn't dimension to it, but I at least put it on there as just kind of like, it kind of shows that those are all on the same center bolt circle. The other thing I showed that I need to reshow is that I did mess around with this is just the hatching is the default hatching, which is kind of the general hatching, which I think if you look up in our book in that sectioning chapter, it shows a bunch of different hatch patterns and their ANSI call out numbers. Because this is a little confusing in Inventor. You may have to have a reference manual to know. Let me escape there. So your hatching is kind of selectable here. If you double click in here, you get access to the ANSI standards, but you may have to know these. 32 is steel. It's like two lines kind of the other one the default is cast iron, which sometimes it gets left as the default standard on a lot of sectioning because it's general purpose or cast iron. This one is specifically steel, and so it looks like a double line, a little bit different than that cast line. So that's all I did is I changed that and I just said okay, and then I changed this property to that as well. And then it already does it opposes those two so they can see the different materials. I didn't go in and change these, but they are selectable too. I just left those as there's only a couple marks in there, but so that's how you would change hatching. So I said that I would do, oh, and these would need center lines as well, right? Don't forget to put a center line through there and center line through that bore. both of those. So I've got, and then let me just take a quick look at anything else on those other sheets that I thought. Yeah, the count, maybe I will drop this on there and just check the view labels, what I thought. And then everything else is pretty easily dimensionable, a couple section views. So let me jump over just I'll just drop a part on there on sheet two. So before I move over there though, I'm actually on one of my copy. I'm actually not on my it's interesting. Like just because I wasn't paying attention, and so my first sheet is this one. This is my sheet three. So I've just messed up. Let's see. Let's see. I think I can just drag these above. Yes. Now this is sheet one, that's sheet two. So these are drag and droppable. So if you do that, what I just did, you can reorient the order of your sheets just by reorganizing them over here. This is the one that I did. Is my assembly, and so it's one of my copied sheets actually, but I just changed it to sheet one. It picks that all up. That's great. It's a pretty easy little fix. I'm going to rename this. I'm going to edit this sheet title to say that this is. Oh, this is the flange bushing assembly. I'll say okay. That's going to update my title of this sheet. This is the flange bushing assembly. Um, what else is different here? I still need to update the eye properties for me drawing it and the date. And so I can do that here, right? This is eye properties on the sheet. And this will be the same for all sheets. I am the drafter here. This is rev number 0 on this particular date. And so if I apply all these changes, that's quite a bit of what's going on here. There's my rev 0. Haven't had it checked yet or approved, but this would need to be filled out. I've been filling these out and the dates maybe to match at least the initial dates when they go down as a rev 0. I'm probably missing stuff, but you can probably catch me. So I'm going to jump over to sheet 2, which is now kind of this sheet. And I only need 2 sheets, so I can just go ahead and get rid of this one so I don't mess up again. But I know that I only need 2 sheets, so I'll get it down to 2 sheets. I'm on my second sheet, which I'm going to place my parts here. So I can look at these parts. There's one, their part, there's part. I'm going to place this one, so I'm just going to look at it, jump over to my sheet, go ahead and just do that base view. It'll be my default selected as the last one I looked at. We need that plus maybe an orthographic and then a section view of this with a view label. So this is all I'm really checking. Is the view label working for me? Yeah, that's that part. So that part number or that part, it picks up its description. I haven't updated any. If I go bounce back over to here, I never have updated the weights here. So I can do that in the assembly on the properties, physical tab, update them, close it, jump back over to my sheet. So it's updated. That's the weight of that. This one, it really is only updated assembly, so it hasn't updated the parts. Those would have to be individually updated, which they are right here selectable. Somebody is, I think so. There's one quick way to get to its eye properties and to do it like while I'm in here and update that and say, okay, close. Now that should update, yes. So I can't just select it on my drawing model browser and look for those eye properties tab without opening the part. Maybe the part has to be open to do that. That'd be interesting for me to check if the closed part will update like that, but still would need the polar center line and some other center lines. I just wanted to show you this. This is where the sheet that I chose to designate, although I put both parts on it, so I probably bundled this over here a little closer, and maybe I scaled it down to fit here. On the second sheet, I don't need this either until there's a revision on that sheet, so I'll delete that. Technically, I might not need, I mean, I can leave this, but I might not need the general notes either. I can always add a note tab here, but I'm not going to add, so I'm not adding anything specific beyond what the general notes that are taking care of me on the first sheet, and that's the master revision history. I wouldn't have one on here unless there has been a revision on the sheet. So let's see. Oh, just this is where I chose to do the size and locating for the counter bore. And because we made that with that whole feature, I can just come up here on my annotate tab and right here, if I pick hole and thread, whatever I've done with that command, I think I can just select here and it'll auto populate this the diameter of the through, the counter bore diameter, and the depth. Doesn't have my amount, so I would have to make one edit here. And I jump into this, which is kind of like a little dialog box here. But I can like bounce around this and come up over here to the front side of that and add my like 4x, right? X with a space. I need four of these counter bores. If I add that, there's my 4x of these going on. So watch your quantities, right? That matters. Same as CAD. And I think that's it. Yeah, I'll do one more time through this. Needs this center of circular pattern. I don't have, I don't, I think I can select this. Yeah, it picks up that. Click on location. The only thing I don't love about this is I should have selected this one as the circular pattern center because I don't have anything else to. On the first time I did it, I already had a crosshair on there. This one I don't, but I can modify this to say, oh, I'm going to pull this out that 6 mm past my part on all sides. I'm not going to need the like that. I can undo that one move that I just did because I'm going to put a cutting plane through here and it's going to take line precedence when it plots over these center marks that are in a line. So I think that's it, you guys. I think that wraps up 15.8. And then you just need to, change your titles, watch your title blocks, finish out your dimensioning, put both parts on here. I don't think I included a parts list on these. Like some people do. I could put a parts list on here for that one. I don't think so. We'll leave it off. This is going to carry my part number. So, and then I would need my other one. So yeah, continue on and watch for center lines. If you dimension like I have, if you find something that's missing here, let me know. Looks like I did a 7/8 size on mine and a 1:1 here. Must have placed that part on there first because my scale on my sheet is being driven by this first place part. And I'm just going to leave it like that. So, okay. That's it, you guys.